Okay, let's go through the practice exam. All right, so the first question looked at a pentagon inside a circle. Vertices are corners of a shape. I'm not too sure what they are. You have to show that the radius is 8.51, so we probably would use this sort of shape. So maybe put in all the radiuses that go to the vertices. Okay, and all those would be the same length. And the only thing then is because it's a regular pentagon, it means that all these sides are the same length as well, which means that all these angles are going to be the same in the middle. So you do 360 divided by how many angles there are there, 5, and that gives 72. Because I'm looking to find an angle in this triangle here. That's 72 degrees. So I have this isosceles triangle here. If that's 72 degrees, this is 10. You can find either or both of these angles. They're both going to be 54 because they're the same size. So from here, I want to find x, one of these radiuses. I think the easiest way to do it from here is use the sine rule. So opposite side over opposite angle. So I'm using these two. And if you rearrange this, 10 times sine 54 over sine 72, you will get x is equal to 8.51. Okay. Next, they ask for the perimeter of the shaded region. So the shaded region is up here. So the perimeter is going to be this curved bit and this straight bit. Okay. The straight bit we know already is 10. So we just need to find the curved bit. So we got to think about what fraction of the entire circle is this. The entire circle is 360 degrees. We have 72 out of the 360 degrees of our circle. So it's 72 3/60ths, which you can simplify if you want, of the full circle. And we're looking for the circumference of the full circle. So that's going to be 72 3/60ths of 2 pi r. So that's the circumference formula. I think the radius is 8.51. We found that out before. Put that into your calculator. You get around 10.7, I think. Radius or. What's the radius? 8.51. And then you add on the 10. That was this. So you had the straight line and you had this curved bit. And it's this plus this. So that's going to be about 20.7. If you rounded it slightly differently, that's fine. Depends on whether you use your pi button on your calculator or 3.14. Try and use the pi button on the calculator. It's slightly more accurate. Find the area of the shaded region. We got, it's not a known shape, so we have to use known shapes. I think I'm going to use this is our shape here. I'm going to find the areas. This is a fraction of a circle, so this is 72 degrees of 360. I'm going to find this area, and then I'm going to subtract the triangle area from it, and I should be left with just the top bit. So the area of the sector, which this is called, is going to be 72 360, the same fraction of the full circle. Same again, the area of the full circle. So 72 3/60ths, 72 of pi r squared. So pi 8.51 squared. We worked that out. All that can be popped into the calculator. You get 45.5, I think. Now that's this entire area. So now I gotta get the area of one of these triangles and subtract it. So I'm gonna subtract the area of a triangle. And I think we use a half AB sine C. for this, because we have if we look at the triangle that we have, we got these two are radiuses, they're the same length, 8.51, 8.51, and we have this angle here as 72 degrees. So it's going to be minus a half, 8.51 times 8.51 sine 72. Work all that out, you get 34.4. Subtract the two together, and you get 11.1 or so. All right. Moving along. Question 2. All right, so it starts off pretty straightforward. Find the volume of the pyramid. So the volume is going to be 1/3 the base area multiplied by the perpendicular height, which is in our formula booklet. It'd be volume of a pyramid base. Yeah, we have it here. 1/3 the area multiplied by the height. You see it. Okay. So the base area, I think if we read this correctly, is 6 times 6. These are both 6. So it's going to be 1/3. So the volume is 1/3 6 squared. 6 times 6 times the perpendicular height, which was 8. And hopefully most of you got 96 for that. The length of Vn then is this kind of slanted line. So Vn is going to be in this triangle. If I pull out this triangle with V, O, and N, imagine this, that's this triangle here. Oh, you can't see that. This triangle I'm pulling out, which is a right angle triangle. Its height is 8. And what is this length? This length here, it's not the full length of the side. It's only half that length. It's 3, I think. I'm sure some of you put 6 in there. And then Pythagoras, 8 squared, so you can call this x. X squared is equal to 8 squared plus 3 squared. X is going to be the square root of 55, I think, when we work it out. So I'll just leave it. You can put it as a decimal if it's a decimal. Is it 65? 73? 8? Oh, jeez. What was I doing? Yeah, that's 64 plus 9. Yeah, 73. Yeah, thanks. Square root of 73. So if you do have it in decimal, nope. You would have got 3 significant figures, 8.54. Okay. And then we get this shape where they cut the top off the pyramid. Anyone get an answer here? Gabe? 84. Turn. 74.6. Anybody else? Oh, pretty difficult question. It is 84. Okay. So we already have the volume of the full thing. If the volume of the full shape was 96, from that's on the previous page. 96. All right. So they've chopped off a pyramid on top here. That's half the height of the original. So there's like this one's been chopped off the top, but it would have all the same angles. It's just a different size. They're like, one is a scale model of the other one. The bit that's chopped off on top is the scale model. When you, I think this comes up twice in the exam. If you have a scale model, they're going to be similar, which means everything's going to be similar about them. They'll be in the same ratio. Figuring out that ratio is not always straightforward because they've given you a ratio. This is 4 in height and the original is 8 in height. So the ratio in one dimension is 2:1. Now, if it was an area, the ratio would be 4:1. And if it's a volume, the ratio is 8:1. I did do that before, but you may have forgotten it. So 2:1, if that's the ratio in a distance, one dimension, It's 4 to 1 if it's an area, because it's going to be doubled up both ways. And then if it's a volume, it's like you've multiplied it by 2 again, 8 to 1. So multiply by 2, multiply by 2. So it's actually 2 cubed to 1. How does that help us? Well, we have the volume of the large one, 96. So that means the volume of the small one that's been cut off, that's not actually in here, is going to be 1/8 of that. So if I divide it by 8, I left with 12 centimeters cubed. That's the volume of the bit that's cut off. So what's left behind? 96, take away 84, or take away 12, which is 84 centimeters cubed. So I gave you already. So it's about recognizing the relationship of similar shapes and the ratios. And always remember this: if it's a distance, the ratio is given in, it's going to be one-dimensional. But if you have to convert that to an area, it's going to be that. So if it's 3 to 1, one is 3 times bigger than the other, the area would be, well, what would the area be? Area, not volume. Yeah, 3 squared, and then 27 to 1 would be the volume. Generally, these are the only two that are asked. To be honest, this is the one that always comes up. 2 to 1 will be 8 to 1 in volume. Okay, and then find the total surface area of this solid. And that's, you have to go back to use those ratios again. Anyone get an answer here? I have the answer somewhere. Gabe, you? Okay. 117 sounds right. I don't have the working out for this, so I can't remember where I left it. So it's got 1, 2, 3, 4 trapeziums and 2 squares. 4 trapeziums, 2 squares. It's not a prism. Anyway, what we have to figure out what this length is. That's the key. We have the height. The height is 4. Why is it 3? Oh, this is 4. This height is 4 because the whole thing was 8 and we took away 4. So the height is 4. This is still 6 across here. That hasn't changed, but we need to find this. Nola? It is proportionate. They're all the same angles. So this angle is the same as the angle here in the small one. But I still need to find this length because I need to do this formula, half a plus b times h. I need to multiply that by, that's the trapezium formula, which is somewhere here. No, it's not on this one. It is 3. But why is it 3?
I split it up. Even though it's not the scale, I just split it
Oh.
up.
Yeah, well, it's a bit of what Nola and Gabe were saying. It's like, if you look at this small, I know my diagram's pretty small here, so I'll put it down here. Okay, so it's, this one's 6. This height is 8, and these are similar triangles. This one's 4. They're similar triangles. The one that's cut off and the one that's there already. So I need to find this, the base of the one that's been cut off. It's going to be the same as the top of the trapezium here. The base here is going to be the same. So you can see from this that this is just a one dimension. This is twice as big, so this is twice as big, so this must be 3. There's your similar shapes. So that's why it is 3. So if we go back to my original diagram here, this length here is 3. And all of them are 3. They're all the same because it's a square. So there's going to be 4 of these trapeziums. 4 of a half times 3 plus 6, a plus b. The height is 4. Plus the 2 areas, 6 times 6. And 3 times 3. And if you put that all into your calculator, which I haven't done yet, Uh, 2 times 9 times 4, probably plus 36 plus 117. Yeah. Who got 117? Someone said that. Oh, nice. Okay. All right. So not easy, like most of this exam. Yeah. Yeah. Okay. Show that. So a number of people were wondering how we show this. That this angle here is 90 degrees. Well, perhaps a way of doing it is call this angle 1 and angle 2 if you want to refer to it down below. Angle 1 is going to be 180 take away 115 because it's a straight line. And that's 65 degrees. And angle 2 is just 25 because it's alternate angle. Did you sign in?
Yeah. So, just say, like, it's because they're together on the line. Or do we have to explain that it's alternate?
You'd have to use the word alternate.
So there's alternate and complementary, right?
Yes, you could use co-interior as well. There may be other ways of doing that. I think that's maybe the most straightforward. It was the way I thought of. I think the key, if you didn't use the word alternate angle, you wouldn't get the mark. There's only one mark. Calculate BCA. So BCA. So this is a right angle triangle. I know that. And we have some distances on it, which first time reading this I actually didn't see. So 60 is here. From B to C is 80. And from C to D, this one, is 75. Okay, so I'm looking at this triangle, the 80-60 one. So we got, I'm going to just draw it out here. The right angle is here in the corner. That's that right angle at B. So if I turn it upside down, that's going to be A and that's going to be C, I think, if we just rotate it a bit. BA is 60, BC is 80, and I forgot what I'm looking for. Angle BCA, okay. That's this angle up here. I think I have the opposite side and the adjacent side. So this is back to your trig ratios that focuses at some stage. So I think you use tan. Tan of the unknown angle, I'll just call it theta, is equal to the opposite 60 over 80. So inverse tan, 36.8 is it? 36.9 degrees, I think. Yeah.
I thought it was.
Tan theta. I just call it, you call it like tan A, tan X, whatever. And then I use inverse tan to get the.
Wasn't it sin, sir? I used.
No, I think sine you need the hypotenuse. We don't have it. This is opposite the right angle.
Oh, but isn't hypotenuse 80?
AC is the hypotenuse. It's opposite the right angle. This one is the one you just proved to be the right angle, so it has to be opposite. Okay, so we found that. Calculate AC then, which is this distance here. You can do this a number of ways. Pythagoras' theorem strikes me as maybe the easiest. 80 squared, 60 squared, x is going to be 80 squared plus 60 squared. And, just make sure we get 100 when we square roots. We do get 100 when we square root. Okay, so I think x is 100. All right, AC is 100. Cool. So that's 100 on my diagram. All right, let's move along. I think, is there more to this question? Oh yeah, there's. calculate distance AD. So that's back. That's here to here. Assume we're going to need to use cosine rule because we have x over here, and we just need to find this angle, which is between these two sides and across, which means we have this angle already, don't we? 36.9. That's 195. We also have this angle in here. These two are co-interior. That's 65. So they make this shape. So these two are co-interior. All right, so I think we have it now. So I'll just take away from 360. 36.9 minus 65 and minus 195. 63.1. Okay, that's what we need. So you see we're dealing with this triangle here, and we got two sides, the angle between and opposite. That's cosine rule. So let's do it. Cosine rule, so you should have x squared is equal to 75 squared, plus 100 squared, minus 2 times 75 times 100 cosine 63.1. Do that in the calculator. So we get 8,008.49. Square root that. 94. Okay. That's that one. And calculate the bearing, everybody's favorite. Anyone get an answer here? The bearing from D to A. So from there. So this is north. A to D, is it? From A, yes. Okay, right. Yeah. So here, going this way. What's that bearing? So this entire angle here we have to find. Anyone get an answer? It's going to be around 100 or so, is it? Anyone get it? No? Gabe? Don't know how to do bearings? Okay. Okay, let's do it. Okay, we go back to my original diagram. What are we missing here? Well, we know this is 90. This is 36.9. I'm going to find this angle, I think. Yeah, this angle is just from 180, so that's where I'll start. 90. I did this the wrong way, but anyway, 36.9, and then I subtract 180. So 53.1 is this one in here. Okay, so I have 25, 53.1, and I need to find this bit now. This last piece of the puzzle. And if I go back to this triangle, I have plenty of information here just after finding what x is. X is 94. So I can use the sine rule, I think. This over this is equal to this over this to find that last. So I'm going to work it out over here, though. So 75 over sine of my unknown angle. Now I'm just going to call it theta. You can call it whatever you want. So that's 75 over this one is equal to 94 over that one. Sine 63.1. A rearrangement of this, you get 75 sine 63.1 divided by 94 is equal to sine theta. Let's do that. Okay, and I get 0.7115. That's equal to sine theta, so theta will be the sine inverse of that. Oh, that's not what I want. All right, second sine inverse, second equals enter. 45.4. That's not the answer. So remember the bearings. Quick recap for Gabe. Bearings are always the angle judged off north. So in this case, our angle is here. You can see where that line is. It's just down here somewhere. So I have to calculate this angle, and that will be it. If it was going this direction, it would be this angle. If it's here's due north and it's this direction, it's this angle. If they're due north and it's there, it's this angle. You always give 3 digits, which is a bit weird. So if this is 30 degrees here, you'd write 0, 3, 0. After 100 degrees, it's going to be 3 digits anyway. Okay, so I just figured out 45.4 is this one. So I think if I add these 3 angles together, I'll get my bearing. All right, Gabe. Okay, 123.5 is the bearing. So 3 significant, 124. Anybody get that? 1. Tricky question again. Okay, so question 4, proportionality. I think the first 2 parts of this were straightforward, and then not so much after that. Okay, so y is inversely proportional to the square root of x. So hopefully we all got to this statement straight away. Multiplying k over the square root. And we get initial conditions, 25 and 2. So what they say with this is write this without k. They want a number instead of k. Write y in terms of x. They can't have a k there. So we'll do that. 2. Y is 2 when x is 25. And I think you get k to be 10 here.
Yeah.
K over 5, the square root of 25. 5 times 2 is 10. So you could replace this with 10. Y is equal to 10 over root x, not k over root x.
Also, that's the answer.
That's the answer, yeah. The second part then, find the value of x when y is 3. So let's use this and find the value for y or for x when y is 3. So y is 3, isolate x. So a bit of algebra for you. If you multiply both sides by root x to get it up here, you get, I think, root x is equal to 10 over 3 or something similar to that with a quick cross multiply. But I want x, not square root of x, so I got to square both sides. So I get x is equal to 100 over 9. Square the top, square the bottom. Now you might have a decimal there. It's going to be recurring. It's not 11.1 all the way. Either's fine. Oh, and then we get to the next part. Okay, so y, or z, and there's 2 things for z here. Z is proportional to the cube of y. Z is proportional to y cubed. Okay. Now, the initial conditions we have are x and z, not y and z, but we have a relationship on the previous page between x and y. Y is 10 over root x. Okay. So instead of this y, I'm going to put in 10 over root x. Why do I do that? Well, because my conditions are with x and z, not or y and z. So if I have this, that's now z and x, and I have z and x. So I can put in and find k. So z is 500, k 10 times root 4. So I put in for x and z cubed. So 500 is equal to k 1,000 over 2. 500 is it? No. No, it's too many. 125. Is it? So it's 2 cubed, 8. Yes, it's 500. 1,000 divided by 8, which is 125. You can do that in your calculator. So k is equal to 4, is it? Okay. Indeed. So I'm putting 4 in for k. And x in for, let's look at this again. Z is equal to 4, 10 over root x cubed. Now, this is a bit of trickery, really, I think. Notice the similarity. So now we're going back here. So the whole question was about finding a and n, and I haven't even looked at this yet. This is what this is. Ax to the n. So this is similar to this. You got an x, you got a number, you got a power. So let's make it look the exact same. So x sits here. So I get 4. Maybe apply the cubed is 1,000 over. Well, what's this then? X root x cubed. Maybe do a sidebar here. Root x to be cubed. Remember, root x is x to the half. And x to the half cubed, or multiplied by 3, is x to the 3 over 2. So you have x to the 3 over 2. So I've applied in the cube to both. So I'm trying to get it look like this. I want x above the line. So 4 times 1,000, if you want to still have it times 1,000. And I can bring this up using my rules of indices. If you remember, it's minus 3 over 2. And 4 times 1,000 is 4,000. Now, if we compare that to this statement up here, ax to the n, a must be 4,000, and n must be minus 3 over 2. Extremely difficult.
That won't be the test, right?
No.
Oh.
Well, that's the hardest proportional question I've ever seen. So, because you have to use the rules of indices out of nowhere, and there is 3 proportionalities, and it was really, really difficult. Anyone get that? No, I didn't expect. Okay. If you got the first 2 parts, you're fine. This is still only worth 3 marks, even as difficult as it was. So, I think they made a mistake making this question this hard. Anyway, let's move on. That particular, I think it was 2018 or 19 that came up. Okay. Logs. Log 5, 25. We need to remember, what this statement is. In general, log 5, 25 equals something. How do I rewrite that with exponents? That means 5 to the power of something is 25. 5 to the power of what? 5 to the power of 2. It's 20. Okay. Second one, you need to use the log rules. There's a minus here, but before we can apply the minus, we have to use the third log rule, which is multiply that 2 up. Log 3 squared minus log is log p. So remember that rule. 2 can go up here. 3 squared, of course, is 9. Yep. And subtraction in logs is division. And p, therefore, is 9 over 5. Now, if you didn't follow that, you need to go and look at the logs questions in the book, or I think there's a couple on the practice questions as well. Okay, question 6. This one. I think this was okay. I'm waiting. This is harder than your actual test. Yes.
Way harder, right?
Way. No.
Like
Your proportionality question will be easier, definitely. And your area volumes questions would be similar difficulty, similar to what the practice questions are as well. And I think the rest of the test was okay. Anyway. Good for you. BAD. Find this angle here. I can already just write in this one as 50 because I know that's a straight line. These two is cyclic quadrilateral, so 180 take away 50. I guess 130. Hopefully you all got that. And angle ABC then. Well, I know this is 130. Okay. That means this and this have to add to 180. 6x plus 9x equals 180. Opposite angles in the cyclic quadrilateral. 15x is equal to 180. X then has to be 180 divided by 15. And x is 12. X is 12. Yes, Lynn. Yeah. And then multiply it by 6. Why do I multiply it by 6? Because it's this one. It's 6x. It's not 1x. I found what 1x is here. So times 6 is 72. Next one, the volume of a sphere is this. Find the radius. So the volume of the sphere formula, 4 over 3 pi or cubed, which you don't need to know off by heart, over 3. Okay. I think if there's pi on both sides, they cancel. Dividing by 3 on both sides, they cancel. And we're left with 4 or cubed is equal to 32. Divide both sides by 4, get 8. Or cubed is 8. What is or? It is 2. Bearings again. The bearing of point B from A is 234. Okay, let's draw a sketch. North, always put in north if you start off with bearings. So point B from A. So we start at A. Here's A. And point B looks like it's down here somewhere. 234. So it's past 180, but not quite 270. Yeah. So B is down here. Find the other way around. So if I put north in here again, I want to find this angle here, this inside angle, to bring it back this way. Okay. I think there's alternate angles here. If I know this angle, this angle, these two are alternate. They make the Z shape. So this is just what beyond 180. I think if that's 180, this has to be 54 because 180 take away that, which means that is 54. So 054 is the bearing. Next. Yeah, put the 0, yeah.
So if we don't put it, what happens?
I'd probably give it to you. I probably think the marking scheme does give it to you, but it's not a correct bearing. So try and remember. Yeah. Bearing is 3. Okay, next one. A, B, D are points from this circle. Calculate the angle DAC. DAC, this one up here. Well, this one is the angle at the edge. This is the angle at the center. This is going to be double that one. If I know this one, I know that one. I could find that one, 20, because these two are isosceles, or this is isosceles because 2 radius, which means that this is 140, 20, 140, 20 make 180. And this is going to be half that, so that's 70. Not double it, half of it. Okay. Last 2 questions. Now, find angle ABC. So ABC, that's this angle here. Note a cyclic quadrilateral. This is 60. This one has to be 120 because they add up to 180. 120. And the last one, ACQ. ACQ. All right, so we're noticing now from our circle theorems that this is a tangent, which means OC is 90 degrees. So whatever this angle is here, remember we're looking for this angle, but this angle, if you take it away from 90, will give you this angle. And I think we can get that angle because we have this one already figured out to be 70. This is the rest of that circle here, so that's 220. And then it's a 4-sided shape in here. I think you could do it another way, but this is the way I did it. 40 plus 70 plus 220 is whatever. 330. So there's 30 degrees left in this spot here. That's 30. And that is going to be 60 then, because they add up to 90 degrees because this is a tangent.